Number 41, integral sine of square root of x dx. If you've been following along this series, we've seen similar integrals before. How did we tackle it? If you haven't been following along, you just watched, you only came to this video. The hint is it's a composite function. So maybe we can make a substitution and then the integrand will become more recognizable. So this is the same as what we did before. Okay, so let me zoom out a little bit. There we go. Okay. So we can let t be square root of x. We can square both sides before we differentiate. T squared is x. 2t dt is dx as a result. All right, so we substitute sine of square root of x. That's just sine of t. And then dx we found as 2t dt. Does this look much more familiar now? This is hopefully familiar if you're studying for an exam. At this point, this should be a recognizable integration by parts. Okay, so I set up the tabular method over here. I picked my u as 2t, differentiate until we get to 0. Sine t is my dv, and then integrate it just as many times. Start from plus, alternate sign, and then we go across and down. So plus 2t times minus cosine t, so that's minus 2t cosine t. And then minus 2 times minus sine t, that's plus 2 sine t. And then don't forget plus c. And then we back substitute. What is t? T is square root of x. So this is my final answer right here. So you can see it's just a study tactic. If you have a professor that gives a bunch of integrals that came from past exams, this is probably likely a problem that you should know how to do because it came up, at least in this problem set of 50 problems, it came up at least 2 times already. It came up multiple times for sure. So you should know how to do this. All right, hopefully this was helpful. Hopefully see you in the next video as well. Bye.